everyone. In the previous class, we discussed about microstate, macrostate, distinguishable particle, indistinguishable particle, and we try to understand all this term, all this thing. So now today I am going to ensemble part. Ensemble part. So what actually the ensemble is? Why ensemble is we need ensemble in statistical mechanics, and what is the physical meaning behind this ensemble? So today I'll teach you all this thing here. So if you go to the definition, then ensemble means it's a large collection of system. It's a collection of systems, large collection of system. And how, whatever the system is, all the system is microscopically different, but macroscopically same. So what is the meaning behind this? So let's suppose we draw first go to the basic, like in definition of the book. Then I'll go to the, I'll understand, I'll teach you very better way. So let's suppose this is a collection of some system. We put some system together in a diagram, and this system is, whatever the system is, all the system is microscopically different. Its internal structure is different. Microstate means internal orientation. It's let's suppose in this system there is n number of particle is there, its volume is v, energy is e. All this system, all the system present in this ensemble is same. N, v, e, all this external factor is same, but it's like the orientation, the energy level, how particle is distributed in different type of state. Its internal structure is different. Internal orientation, microstate is different. I hope you understand microstate and macrostate in my previous lecture. So this happens here. Here total macrostate, let's suppose NV is same here. NV is same for all this particle is same here. So this is the definition of ensemble is. And but you will not understand what actually ensemble is from this definition. Why you need this, all this type of thing, why you need this collection of system in the first place. So I will teach you this regarding this. So to know all this thing, you have to first know phase space. Phase space. You have to know phase space. Actually, there is some connection between phase space, ensemble, and microstate. There is connection. You have to know this connection, the relation between all this type of thing. Actually, what do students do? Teach, learn all these things separately. But you have to know the relations between them. You have to connect this, all these things, three things. Then you will understand the statistical mechanics better way. So first I will go to the phase space part. So I'll go to the phase space part now. So what is the phase space actually? Phase space means a QP space. I hope you learned this in earlier this QP space. Let's suppose it's P axis and Q axis. Let's suppose a particle is moving in a one-dimensional line. So can you define its position and momentum in a plane? This is the position, this is the momentum, and this is the position. Let's suppose we define this particle here. At a particular time, this is the coordinate of this particle in position and momentum space. This is called the phase space. This is the phase space. Right? I hope you understand this phase space. Now I'll come to the two-dimensional. If the coordinate is if the particle is moving in two-dimensional plane, then how many coordinates need here? How many axes important to define the particle at a single point? Here, total number of coordinates is 4. Here qx, qy, px, py. So 4 coordinates is needed here to define the particle at a single point. So what about three-dimensional? Same in three-dimensional case, it's 6 coordinate is needed. Coordinate is needed. Now we'll understand what is the relation between system and phase space and ensemble. Now I'll teach you. What about if in the previous 3 example we told about a particle, only one particle? So what about if there is n number of particle? If there is n number of particle, can we define all n number of particle at a single point? Like in the phase space, here we define as at a single point. If one particle only. Can we define n number of particle at a single point? Yes, we can define. If we consider 6 and axis, 6 and axis or coordinate. You may find some difficulties to understand this because it's little difficult to draw that much coordinate, all this type of thing. Here you may confuse, like it's two axes only there. No, it's here 4 axis is there. It's difficult to draw, that's why I cannot draw here. So if we draw 6 and axis, then we define a system of 6 and particle, n number of particle at a point in QP space, and this called gamma space. Now you may confuse what is the gamma space and difference between gamma space and phase space. There is nothing different. For one particle, it's called phase space. For more than one, like n particle, we call gamma space. And definitely for n number of particles, their axis will be n times higher than this one particle. So that's here need 6n dimensional, 6n axis. It's important. It's have to draw. To define this particle, we have to draw 6n axis. So I hope you understand gamma space. Now I will relate this gamma space to ensemble. So what we will do in statistical mechanics? We study about a system. It may be gaseous, it may be liquid, anything. Let's suppose the particular volume, particular number of particles is same at the system when times evolves also. Let's suppose there is n number of particles there. And we define all this n particle in gamma space. Let's suppose this is the position. Now you understand that. Now you can relate the system, a physical system which we study in thermodynamics or statistical mechanics, to the gamma space. You can relate this. You can relate this now. So what happened? In this system, macrostate is same. Like suppose we restrict the system. You give some restriction here. What about the restriction? Its number of particle cannot be sensed. Like its wall cannot penetrate the wall. Particle cannot escape from this volume, and its volume is same. Volume remains same. It cannot expandable. Its length, breadth, and height remains same. So we give some restriction. So this is the macrostate. This is called the macrostate. The property we can study from outside point of view. It's called macrostate. The macrostate property. But what about its internal structure, its internal orientation, its internal movement, all this type of thing is related to its microstate, like internally which getting sense with respect to the time. So its microstate will sensing with respect to the time. Its microstate will sense. Why microstate will sense? Because let's suppose it's gets some heat from outside. Its internal structure will getting sense. So its microstate will be sensing with respect to the time. Let's suppose at a particular time we define this system at this point in QP space. What about after some time? After some time, we cannot define at the same point because it will evolve with time. As the time going on, it will evolve. Like its internal structure will getting sense. Internal structure means its microstate will getting sense. So we may locate this particle at this point. So when the time going on, when we take a broad amount of time, we get so many points in the QP space for a particular system. System is same. System is not changing, but we get so many points here. So this all the collection of this point if we put all this collection of the point in a single diagram, we put all this collection. This is, let's suppose this. In a single diagram. Let's suppose we put this here, we put this here, we put this here. All this we put in a single diagram, and this diagram is called ensemble. Now you connect this phase space, system, phase space, and ensemble. You must know the connection. Then you will solve the problem, some advanced problem. You will better understand the statistical mechanics. Without knowing this fact, you will not understand statistical mechanics. This is the actually physical meaning behind the ensemble. So this is related to a system. This is related to this system, this system, this system, this system. At a particular time, after some time, the system, this is related to this system, this is related to after some time this system, same system, but time is different, and its microstate will get different. How microstate will get different, I've already told you here. Its microstate is different. So now come to the definition of ensemble. A collection of system. This is the collection of system which macrostate is same. All this macrostate is same because here let's see N, V, all the same for the system, but the microstate is different. Like QP space here, all is different. All is different here. So this is the actually physical meaning behind ensemble. Now I hope you understand what the ensemble actually is. Now I'll connect this ensemble and microstate. So what is the connection between microstate and ensemble? Microstate, system, and ensemble. There is connection. Let's suppose in the phase space I told you there is so many points there in phase space of a system. This is the system. So many points in phase space, and all these points we connect in ensemble. Ensemble. All this point. So now I already told you all these points represent microstate, different microstate. In the phase space, in the gamma space, we put all this possible microstate here. All this possible. There is large number of microstate is present here, and here all this microstate is related to a system in ensemble. This is the ensemble. In the ensemble, all this point, all this system is related to a microstate. So can you conclude this from these two diagrams? Can you conclude this? This is a great big statement actually. The number of microstate present in a gamma space equal to the number of system present in ensemble. So number of system present in ensemble actually is the number of microstate present in gamma space, and same number of microstates also present in the system. The system can have that amount of number of microstate which I draw in phase space. Phase space means gamma space. Phase space and gamma space are relatively same, so I use this same term for every cases. So you have to know this, because number of microstate you should calculate in when I will teach you microcanonical ensemble. In the microcanonical ensemble, there you have to learn how to calculate the number of microstate. It's very important there to know the number of microstate of a system. So I hope you understand the ensemble today. What actually a physical meaning behind the ensemble. So tomorrow I will teach you the different types of ensemble. why we need so many ensemble. Three ensemble is there. Why we need three ensemble? So I'll teach you to tomorrow, and after that I will teach you the go to the all this type of ensemble. Then there will be in the canonical ensemble will be a term like partition function. I have to teach you this also. So I hope you understand all these things today.